All right. So, last Friday, and I apologize if you were not here, we did move on. Last Friday, we talked about sequences. So today we're going to finish up our 7.1 notes. So last Friday, we talked about sequences are just like these lists of numbers. Terms are the specific numbers in the sequence. You can have finite sequences that have they have an ending point, and infinite sequences that'll go comma, dot, dot, dot. We wrote out terms in a sequence given a rule. We then did the challenging writing a rule for given numbers in a sequence. We had a couple tricks with that, right? If we wanted to change signs, we did -1 to the n, would give us negative, positive, negative, positive. -1 to the n, either +1 or -1 would do plus, minus, plus, minus. And then we wrote out rules, and this was quite challenging for us. We're going to skip graphing sequences because the other class is not doing it. Not that it's anything too crazy. It's just your horizontal and x-axis are slightly different, what they mean. So today, let's talk about our next definition, and these are called series. So series occurs when the terms of a sequence are added up. So now instead of having commas, you'll have addition or subtraction in between the terms, depending on if they're negative or positive numbers. So there is some cool notation that you probably have not seen before. It has two kind of names. So summation or sigma notation. Summation or sigma notation. My pen is about to die, so I'm going to swap pens here. So do you remember when we were doing in chapter 6 the little this guy? Okay, this was our lowercase sigma that stood for standard deviation. Now, unrelated, other than that, it's the same Greek letter, but now capital. We have a capital sigma is the notation for writing out a series. So let me give you sort of the layout of these. So I equals is going to be where you start. So it's going to be, for most of the problems today, it's going to be I equals 1. Okay, we're just going to start at 1. The reason is when we do some tests later on, you'll want this to go from 1 to infinity. So in general, we're going to start at 1. It's unfortunate because sometimes series are easier if you start at like 0. I think there's one in your homework that if you started at like -1, it'd be super easy to write the rule. But for your homework today, you're going to start at I equals 1. And then this top number is what you go to. So this will be your ending point or your ending index. And then those rules that we wrote out yesterday that you kind of struggled with, that's going to go right here. And generally, you'll want to put a parenthesis around it, especially if it's like a number plus another number, because you want to make sure it's clear that the sigma or that sum is acting on all of that. So just like with sequences, you can have finite series or infinite series. So finite series, for example, would look like 2 plus 4 plus 6 plus 8. And the rule for this, and I'm going to rewrite the series just so you know which one I'm talking about, 2 plus 4 plus 6 plus 8. The rule for this would be written as that uppercase sigma. We would start at I equals 1 up to 4, and the rule would be 2i. So again, on Friday, we used n's. In general, we're going to use i's here. If you can't see why that is the rule, notice that this is 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4. Okay, that's why that rule works for it. Where I is just your index. And the reason it goes to 4 and not to 8 is because it's your highest index, not your highest number. That was a misconception that second hour I had that I noticed. So it's actually your highest index, not just your highest number. That is a finite series. An example of an infinite series would be this 2 plus 4 plus 6 plus 8 plus ... And really the only difference here, you still have that uppercase sigma. Now we're going to start at 1. Our rule is still 2i, but now we're going to say your highest index is infinity because it's going to go on forever. So if you have an infinite series, your highest upper bound there, that index will be infinity. So for both series, the index of summation is I, and the lower limit of summation is 1, meaning that starting value. The upper limit of summation is 4, for the finite series and infinity for the infinite series. Summation notation is also called sigma notation because it uses the uppercase Greek letter sigma written as that sideways M. Any questions about the notation? Okay, so I'm going to ask you to do two things today. Example 4 is the most challenging thing. It's where we write the rule with that sigma notation given the list of numbers. So this is what you all loved doing on Friday, okay? So you're going to start out here. Does anyone see what is the rule? Okay, so you remember you're right, it is plus 25. Do you remember on Friday, what did we talk about? We don't want to just do plus 25. Multiply. So yeah, if you see it's increasing by 25, I want you to multiply it by 25. And let's make sure this works. So it'd be 25 times, if we have to start at 1, times 1. Plus 25 times 2 for our second index. Plus 25 times 3. Plus now we have this gap. It's sometimes a little hard to see what we went up to. 25 times what is 250? 10. So this goes up to 10. Okay, so it does help to write it out this way because now I know for sure that my index is going to start at 1 up to 10. And you just told me the rule, it's 25i. Okay, not terrible. Let's look at part C because it's a really similar rule. What's happening here?
5 times 5i.
Right, we're adding 5, so it's 5 times I because that's the increment that we're increasing by. So this is 5 times 1 plus 5 times 2 plus 5 times 3 plus up to what gives us 100? 5 times what? 20. So then my summation will start at I equals 1 because again, we're just going to start at I equals 1 for our homework problems. Up to 20, that's that upper bound, and it would be 5i. I don't need parentheses around the 5i here just because it's just multiplication. But some of your homework problems, they're going to be a little picky about parentheses. Sorry. Part B, this one's a little trickier. If I cover up the denominator, does anyone know what's the pattern if I just cover up this denominator?
N.
Okay, it's just I or N or whatever index thing we're using. Yeah. So I definitely can see you can kind of start this out. You can start your summation. I know there's going to be a fraction, and we're going to call it I. And we start at 1 because that's the first number. If I cover up the numerator, what's the rule?
N plus 1.
Or I plus 1, exactly. Yeah. So this one was really truly an addition. And it works there. And again, if you're not sure, you can kind of just test out. I usually I get to the first one, and then I test to see if that rule that got me to the first one works for the second as well. So I over I plus 1 would be our rule. What are we going up to? Infinity. Because this doesn't end, we go forever. So we want to go to infinity. Part D. Do one more of these. What's the rule for part D? What's happening here?
6 to the power of I.
Yeah, we're seeing it's not just doubled because it's multiplying by 6 each time. So if you're familiar with your powers tables, this is 6 to the first, this is 6 to the second, this is 6 to the third, 6 to the fourth, and so on. So our rule, we're going to be at I equals 1 to infinity of 6 to the I. I think on your homework today, there's one of them that has a power. You'll want to put the base in parentheses. It doesn't really matter for this one. But on the homework one, I think it's like a negative. So you'll want to put it in parentheses if that happens. Any questions about this? I know spotting the rules is hard, but are we okay with the notation so far?
Yeah.
Okay. So we didn't do any addition. Let's look at some of these that are actually adding. So we kind of already talked about this because you keep telling me N, which is, for the record, fine. So this is the index of summation. The index of summation for a series does not have to be I. Any letter can be used. Also, the index does not have to begin at 1. So for instance, the index begins at 4 in this next example. So when you write a rule, I do want you to start it at 1 for now. I think it might be fun to spend a day shifting that index and seeing how it changes our rule, because I do think that helps us understand the rules a little better. But for today, let's leave it at 1, except for these examples where you actually have to find the sum. So when you're actually finding the sum, It's a bit tedious. This example is the sum of 3 plus k squared from 4 to 8. So that means that I'm going to have to write each of these terms out. So it'd be 3 plus 4 squared plus 3 plus 5 squared plus 3 plus 6 squared plus 3 plus 7 squared plus 3 plus 8 squared. So fortunately, it's only going from 4 to 8, because if this was going any higher, that'd be unpleasant. So this is going to be 19 plus 28 plus 39 plus 52 plus 67, which turns out to be 205. Okay, so you can see how tedious this would be, but are there any questions about how I substituted stuff in? Not terrible. Could be tedious if I gave you like 420. I think you would all want to revolt. We do have a couple tools to help us with this though. So let's look at these special formulas. So for series with many terms, finding the sum by adding the terms can be tedious. That's what your book said. I didn't even say that. Below are formulas you can use to find the sums of 3 special types of cases. So let's look at this first case. Sum of n terms of 1. So this is saying that the sum from I equals 1 to whatever your max value is of just 1 equals n. So let's see what they actually mean by that. If you look at example C, this matches that form here. And really what's happening here is there's nothing to plug in for I. All this is saying is it's 1 plus 1 plus 1 plus 1 plus 1 plus up to plus 1 34 times. Well, how many must that be? It must be 34. If you go back to preschool or whatever my toddler's doing in whatever class he has, daycare, when they're counting, if he says he has 10 pennies, it's because they've set 10 pennies out in front of him. So that means that 34 ones is 34. So that's why this rule works for if you have a 1. And I want to make sure we're clear that we're not actually changing the number that we're plugging in. You're just doing it 34 times. Let's then look at this next rule, which is the sum of first n positive integers. So this one is the sum of I from 1 to n, or to your maximum, is this your maximum times your maximum plus 1 divided by 2. Now, I apologize, the book switches between using n's and your index, and so it's a little confusing because in this definition, it's saying n is your maximum bound. So if you look at part D, now they're calling the index n, just to confuse you, but really the n from this formula is this upper bound. So how you would use this here is you would say, okay, since this is only talking about the index, right? That's the only rule here. Then my formula will be the upper bound, which is 6, times 6 plus 1 all over 2, which would be 6 times 7 over 2, which ends up being 21. What is happening in this formula, and again, you could count this up by hand. What's happening is that it's 1 plus 2 plus 3 plus 4 plus 5 plus 6. So you can check that that is, in fact, 21. And it's fine to do it by hand from 1 to 6. But again, if I give you 1 to 20, nobody wants to do that by hand. So that formula is really nice. What about part A? Does that look like that formula? Kind of. So what if we just factored out the 8 part? So what if we said this was 8 times? Now, again, it's our upper bound, which in this case is 5. So it'd be 8 times 5. And then it'd be 5 plus 1 all over 2. Well, that's 8 times 5 times 60, not 60, geez, 6 over 2. And again, we sort of want to be careful with our order here. We want the 5 times 6 first, which is 30, divided by 2, which is 15. So it'd be 8 times 15, which is 120. That's how you can sort of manipulate these rules to look like the rule you want. Questions about that one? So you can always factor out a number if that's an issue. This last rule, I apologize, I don't have a version of it in your notes. It definitely is in your homework, but not in your notes. It's the sum of squares of first n positive integers. And so again, it's this complicated rule with your upper bound. It'll be divided by 6. It does not work for part B, and it doesn't work for a couple reasons. I thought I could make it work by, I saw that there was 5 total numbers here, so I thought maybe if I subtract 5 to that k squared, it would work. But another issue is we're not starting at 1, we're starting at 3. So it ends up not working. So we do have to do this one by hand. So sometimes you can't make it look like the formulas. So you just have to do it by hand. So this one would be 3 squared minus 1 plus 4 squared minus 1 plus 5 squared minus 1 plus 6 squared minus 1 plus 7 squared minus 1, which would just be 8 plus 15 plus 24 plus 35 plus 48, which ends up being 1/3. Any questions about these series? Pretty nifty. I want to show you some things with your homework because Go Formative isn't as perfect as I wanted it to be for our homework today, unfortunately. Okay, so for your homework assignment, this is first one's a fill in the blank. The second one will not auto grade. I have to go through and grade those because that's kind of like a free response. For the 3 through 8, you're actually going to you're going to write the summation in summation notation. Make sure you're using I for the index and then start at I equals 1. There is I think number 3, definitely number 5 would be way easier if we could shift that index, but I don't want us to. I want us to practice using 1. The summation sign is in this math keyboard right here. If you click on it, it even gives you a space for the upper and lower. And then, like I said, this will be pretty picky about parentheses if you have any addition or subtraction going on. 9 through 12. So I don't know why, but for whatever reason, this summation thing, it squishes the bounds when I type it into your problems. It doesn't do that when I actually had the problem. So if I just look at the actual, sorry, I got grades up there, geez. If I actually look at the problem, and again, pardon all my answers, but when I typed this in, it gave me, it looks normal, but then as soon as I hit done, it squishes it. So I send them a thing because I don't know why that it looks like that, but that's what's going on there. Deal with it, I guess. I messaged them this morning. They haven't messaged me back about it because it's really annoying me. Yeah, it's driving me crazy. But anyways, that's your lower bound. That's your upper bound. So you have the rest of the hour to work on this. If you get stuck or need help, let me know.